In this video, we're going to demonstrate how to write an explicit function equation and use it to find the nth term for an arithmetic or a geometric sequence. We're going to begin with the first two examples here with arithmetic sequences, and the next two examples will be on finding the nth term for a geometric sequence. So let's begin with our first example here. We have the sequence 9, 16, 23. All right. The general explicit formula is this f of n equals d times n minus 1 plus a sub 1. Okay, a lot of letters coming at you, right? So n represents the term number, all right? D represents the common difference. And a sub 1 represents the first term value, or a lot of times we call it the initial value of the sequence. So looking at 9, 16, 23, our first term value is 9. So our a sub 1 is 9. Our common difference, well, let's figure it out. 23 minus 16. Well, 23 minus 16 is 7. All right, 16 minus 9. Well, that also is 7. So our D, our common difference, is 7. N is the term number. So in this problem, we're trying to find the 57th term value. So in this example, our N is 57. So those are the three pieces of information we need in order to write the function equation and to solve it to find the nth term value, in this case, the 57th value. So let's do it. We're going to write, instead of f of n, we're going to say f of 57. That's our input. We're trying to find the 57th term value. Equals the common difference, which is 7, parentheses, the n minus 1, so we're going to put in there 57 minus 1, close the parentheses. And then it's plus the initial value, so plus the first term value, which was the 9. All right, now we're just going to simply follow the order of operations to simplify the equation, which is the expression on the right side, right? The f of 57, this is function notation, is going to stay that. So this is always going to be f of 57. Okay, that's not going to change. All right, so then we're just going to change the right side of the equal sign, which is that expression. We're going to follow order of operations. So we're going to go 7 times 57 minus 1 is 56 plus 9. All right, so now we're going to go, okay, f of 57 equals 7 times 56 is what we do next, right? Order of operation, do multiplication before we do addition. So 7 times 56, let's see if I can do this in my head. 7 times 50 is 350, and 7 times 6 is 42, so that's going to be 392. So it's 392 plus 9. Okay, and now we're going to do the final step. F of 57 equals 392 plus 9 is 401. So the 57th term value in this sequence is going to be 401. Let's do another example with arithmetic. So this time we have the 82nd term value we're trying to find. So that means our n is 82 this time. Okay, our common difference we got to figure out. So let's see, we're going to go 961 minus 967 equals negative 6. All right, 967 minus 973 equals negative 6. So our common difference is negative 6, so that's the D. All right, our initial value, the first term value, that's the 973. So that's our a sub 1. All right, now we're going to substitute those into the explicit equation. And we're going to write, we got f of 82 equals negative 6 multiplied by the 82 minus 1. Sorry, I'm trying to run on the screen here. It's a little chicken scratchy, but best I can do right now. All right, and then plus our initial value, which was the 973. Okay, so now we get f of 82 equals negative 6 times 81 plus 973. I'll use a calculator on this one. So now we get f of 82 equals, calculator says it's negative 486. I guess I could have did that in my head. Plus 973. And so then we go ahead and add those. F of 82 equals 487. So the 82nd term in this sequence is the value is 487. Let's switch gears now and let's look at writing an explicit equation for a geometric sequence to find the nth term. So our formula is a little different. It's going to be f of n equals g sub 1 multiplied by r to the n minus 1 power. So the n is still our term number. We don't have a common difference with geometric sequence. We have a common ratio. So we're going to use the variable letter r to represent common ratio. And then instead of saying a sub 1, sometimes textbooks use a sub 1. We use g sub 1, just the first term of a geometric sequence. So it's the initial value of our sequence still. All right. So let's go and do it. So it says our example here is find the 7th term value. So our g sub 1 is, what's that, 100,000. 100,000. That's our initial value. Our n in this example is 7. We're trying to find the 7th term value. And then our common ratio is 4,000 divided by 20,000. Well, that equals 1/5, or 0.2. And then if I go 20,000 divided by 100,000, that gets me also 1/5, or 0.2. So I'm just going to use 0.2 up here. 0.2. I'll probably use a calculator to calculate these. All right, so now we have our information we need to input into our explicit equation. Let's do it. So we're going to say f of 7, because our n is 7, equals our initial value, 100,000, multiplied by our common ratio, which is 0.2, but that's raised to the 7 minus 1 power. All right, so then we're going to say, okay, f of 7 equals 100,000 times 0.2 to the 6th power. So now I need to use the calculator. All right, so calculator helps us out. So we go f of 7 equals 100,000. We took 0.2 to the 6th power, and we got 0.000064. Okay. So now we're going to use the calculator again, go 100,000 times 0.00064, and we get f of 7 equals 6.4. So this is an example of a geometric sequence that is decreasing. Common ratio is only 0.2, so it's decreasing pretty quick. So by the time we get to the 7th term value, you're already down to 6.4, even though you started at 100,000. All right, let's look at the next example. Let's use green. All right. We're going to find the eighth term value this time for the sequence, which is 0.528. So our n is going to be 8. That's the term value we're going to find. Our g sub 1, our initial value, is 0.5. And our common ratio, let's do the work over here on the left, we're going to go 8 divided by 2, which equals 4. And we're going to go 2 divided by 0.5, which also equals 4. So our common ratio this time is 4. So this example, our sequence is going to be increasing, which we can see it's increasing, but increasing at a rate of, we keep multiplying by 4 each time. All right. So we want to, yes, could we figure this out? There's only eighth term. Could we figure this out by just multiplying each term by 4 and keep doing it until you got to the eighth term? Yes, you could. But we're trying to teach you how to use the formula here. All right. So f of 8 equals the initial value, which is 0.5, multiplied by 4 raised to the 8 minus 1 power. So then we get f of 8 equals 0.5 times 4 to the 7th power. All right, so we use the calculator. We go f of 8 equals 0.5. 4 to the 7th power is 16,384. So times 16,384. And then our final answer, f of 8, equals 0.5 times 16,384, which is 8,192. All right. So your key to success here for finding the nth term value is, one, you got to know, is it an arithmetic sequence you're working with or a geometric sequence? Because you got two different formulas that you're going to use to find that value, to write the explicit equation and find it. So you need to know, is it arithmetic or geometric? And then you simply, once you know the term value, the term number, I should say, that you're going to find, the n value, you know either the common ratio or the common difference, and you know the initial value, you have that information, you're going to be able to find the nth term every time. Hope this was helpful. Thanks for watching.